Welcome to the course of Network Protocols. I'm your instructor Zeeshan Bangash, and today we will be discussing about the second part of Interior Gateway Protocols session. This is lecture number 20. Let's move to the outlines of our today's discussion. In today's discussion, at the very start, we will be discussing some of the challenges and the basic concepts related to the hierarchical routing, and then we will differentiate between the intra-autonomous system and inter-autonomous system routing. Then we will discuss some of the issues related to routing in the internet, particularly the network layer, and we will be discussing in the last part of our today's discussion about the hierarchical in autonomous system routing and some protocols that are inter-autonomous system routing like RIP, OSPF and hierarchical routing. So let's move to the first agenda item, that's about the hierarchical routing. Now, whenever we consider the internet and particularly the issues related to routing, so we consider that ideally all the routers are having the same platform, that's they are identical in terms of the platform. Secondly, they are identical in terms of the routing protocols that are executing on these routers, and the network is flat. The topology of the network is not dynamic, it's not changing. It's a lot of most of the topology is static in nature. So this is basically the ideal situation for a network, for a networks of networks. However, in reality this is not possible. It's not practical when we consider the uh, internet environment or the wide area network environment, because there are a lot of different networks that have different platforms, and the topology of that network continuously changes. So let's consider that the scaling issue, that there is a scale of 50 million destinations in the internet. There's a change in the topology of the network with the addition of 50 million destinations. Now, the router cannot store all the destination in a single table, or the router cannot update or manage all such changes locally or individually. Secondly, when this information is going to be exchanged with other routers or with other networks, so that can just damage the link. It will create a lot of congestion, and that will again create challenges for the communication. So these are the two issues that are related to the routing, particularly when we consider the issue of scaling. Secondly, the next issue is related to the administrative autonomy. Now, what is internet? Internet is basically the network of networks. It's a wide area network. However, each admin belonging to any network that wants to control the routing in its own network. So if that table have details about the large part of the wide area network, so the administrative autonomy is not possible practically. So for that, the idealization that the all routers needs to be identical and the network is to be flat, that's not practical. So here comes the concept of that hierarchical routing. Now what happens in that hierarchical routing, that the whole network is divided into different independent regions, and we call it autonomous systems. We say that the aggregate routers divided into regions, we called them AS, and router in the same autonomous system, maybe the single administrator or maybe the group of administrators are running a single autonomous system, they will be running the same routing protocol. So for this autonomous system, there is administrative autonomy. For the challenge we talked in the last slide, that in large network the administrative autonomy is not possible. However, in case of the hierarchical routing, when we divide the whole region into different autonomous systems, so administrative autonomy is possible. That will help into better manage and control the region for which that administrator have that domain. Now, as far as the autonomous system division is concerned, the routing is divided into intra-autonomous system routing protocols and inter-autonomous system routing protocol. Now, routers in the different autonomous systems now that can run different inter-autonomous system protocols. Now there is a division or the segregation of some routers that will be given the role in the network as the gateway routers, and that differentiation is basically on the base of the role they are playing. These gateway router protocols are special routers in that autonomous system. So we will be looking into these division of different routers in the upcoming slide diagrammatically. However, these gateway routing protocols are special in the autonomous systems, and that have been designated as the gateway routers, and they basically run a different type of protocol, a routing protocol. We call it an inter-autonomous system routing protocol, with all the neighboring autonomous systems with which these gateway router protocols communicate. Now they are also responsible, they have also the responsibility of routing the packets, and particularly routing to the destination that is outside the autonomous system of the region for which this router is designated as a gateway. So it have got two responsibility. It's basically work as a router for communicate as one of the role in that autonomous system, and it communicates with the other autonomous systems for forwarding the packet from one autonomous system to another. And for that they have different protocols to perform this responsibility. Now they basically run inter-autonomous system routing protocols with all the other gateway routers in order to perform the responsibility for routing some packets to the destination that are not part of the autonomous system, but they are part of the another autonomous system. So an extra inter-autonomous system routing protocol like BGP, which is the border gateway protocol, we discussed in the previous session, in which we were discussing some of the routing protocols. So the inter-autonomous system routing protocol like BGP, that basically is executed for routing the packets to the destination that are outside autonomous system, and this protocol is the inter-autonomous system routing protocol. Now let's consider diagrammatically the difference between the intra-autonomous system and the inter-autonomous system routing protocol. So in the diagrams, symbolically there are different routers that are physically placed at different location geographically, or maybe or are at different part of the network. And let's consider that we have divided these different routers based on the functionality and the phenomena which we are executing into three different regions. We call it region A, we call it region B, and we call it region C. So you just look into it that this region A have three routers, this region B have only single router, and this region C have two routers. There's another router, you're just viewing it in the diagram that it is not part of any autonomous system, and we will be discussing that thing, that what this router is all about. So just consider that these routers are connected to each other, like this in autonomous system C there are two different routers. We call it router A is connected with B. Similarly, in autonomous system or the sub network A, there are different routers that are connected to each other directly or indirectly, and then there is a connection between two autonomous system from router B to A or from router A to B. Similarly, in autonomous system B, we have different routers that are connected, and this router A is connected to two autonomous system. It is connected to uh, autonomous system A through router C, and this again, this region B is connected to autonomous system C through router B. So this is just a pictorial representation of the wide area network and the division, or we can say it a hierarchical routing in which the whole network is divided into different regions. Now, about that gateways, so we can just highlight it that this A, this C, and this B, these are some of the routers in each region that are connecting one autonomous system to another autonomous system. So what are the functions of gateways? They are basically to perform the inter-autonomous system routing among themselves. So this gateway, like we can just idealize it that this A, C, and D, they are the gateway routers. They are basically uh, given the role to perform routing among the different autonomous systems. Now, there is gateway that perform intra-autonomous system routings with each other routing in the autonomous system. So let's discuss this thing that we have given these different routers a special role. We call these gateway routers. So that have been represented diagrammatically. So this B router is basically the gateway for region C. Similarly, this A dot A, which is a gateway router in small a for the region A. Similarly, this router A, or we can call it B dot A, capital B dot A, this is basically a gateway router A for the region B. Now, let's consider the details about that router. That is a gateway router for the region A. We call it the A.C. So we already know that the router performs operation up to the third level of the OSI model. So the first level is basically the physical layer level. We already know that the physical layer, then the data link layer, and the routing operation is performed at the third level. We call it the network layer. Now, whenever the router receives any packet, we already know it from the previous discussion about routing, that whenever the data is received from any host to the router, which is an intermediate node, it processes that data up to the third level. The data is received by the physical layer, then it is transferred to the data link layer for processing, and then onwards it is transferred to the third layer, which is the network layer, on which different routing protocols like RIP, OSPF, or if in case of gateway protocol, it is the uh, border gateway protocol, executes it processes that data, it it's again add some information to that data, and then that packet is again transmitted to the data link layer, which processes it, and then it is transmitted to the physical layer, and then it is transmitted to the physical medium for onward transmission to the neighboring router. So we are just visualizing that thing, that this network layer manages the inter-autonomous system or intra-autonomous system routing algorithms. Here, based on the role of that router, the different algorithms or the services executes, and the routing table is managed and updated at this third layer uh, as per the communication of data between source and destination. Now, as we already discussed, that this whole communication model is divided into 7 layers, and of which this router or the intermediate node executes only 3 layers, which are the physical layer, link layer, which is the data link layer, and the network layer. Now, you can just look at into it that the network layer processes basically the inter-autonomous system and intra-autonomous system routing in the gateway. We already talked about that thing. Now, let's discuss another slide about this inter-autonomous system and intra-autonomous system routing. So you can just look into this diagram that there is a host H1 which is part of the autonomous system C, and that wants to communicate with the host H2, which is part of the autonomous system B, and there is a direct communication link between two autonomous system, and there's an indirect communication link between two systems, and that's through autonomous system A. However, this whole communication depend upon the scenario of the network. Maybe this direct link is congested and the communication took place through the intermediate link, based on the scenario of that network or based on the congestion environment and challenges of the network. So how this communication took place, and how we divide this inter-autonomous system and intra-autonomous system routing. So we can just view this diagrammatically, that this communication within the autonomous system, you can just look into it. This is basically the inter-autonomous system routing, and then there is some routing or communication between different autonomous systems. So you can just look into it that this green line shows the communication between inter-autonomous system between the autonomous system A or the region A and the region B, and then the host is part of the region B, and then there is again the intra-autonomous system routing that happens within the domain or the region B, which is an autonomous system, and the network or the region where that host or the destination lies. Now, let's talk about the routing issues related to the internet and some basic information. This global internet is basically consists of autonomous system, and that internet is basically the group of interconnected autonomous system that are interconnected with each other. And there are some three terms we used. One of the term is the stub AS, and this stub autonomous system is called or designated to those corporates which are very small. For example, any services you receive from a single internet service provider, from the locality from which your internet services is providing, we called it stub autonomous system, where there's a single internet service provider. There's another multi-homed autonomous system, which there is more than one ISPs that are connected, and this multi-homed autonomous system is considered for large corporations, in which there are multiple ISPs that are connected for communication. And then there is another which we called it a transit autonomous system, and This is basically a sort of provider service, and it's used for routing of data from one autonomous system to another autonomous system. So these are three uh, different terms used for autonomous system. The autonomous system may either be a stub autonomous system, or it may be a multi-homed autonomous system, or it may be a transit autonomous system, and that depend upon the design of that network for which that autonomous system is divided into a specific category. Now there are two level of routing. We already discussed that the routing physically is either an intra autonomous system routing, and there's an inter autonomous system. So two level of routing, we can categorize it. That's one is the intra autonomous system routing, and here the administrator is responsible for choice, and the administrator, as per the design of that autonomous system or that region, the administrator decides or fixed the different parameters for that network. However, there's an inter-autonomous system that's between the different autonomous systems, and that's basically work on a unique standard because that's related to the wide area network communication between different regions. So let's again discuss the OSI layer model and the categorization of this routing protocol, that how and that which to which layer it belongs. We already talked about that thing, and we just want to review the internet network layer functionality. So at the very bottom there is physical layer. It's basically the hardware layer. This is the four these in the diagram we will be showing you four layer out of that seven layer. So the at the very bottom, this is the physical layer. It's basically the hardware through which that bit streams received by either a destination, or it may be an intermediate node, that may be a router. And then there is a link layer, we call it a data link layer, and the different protocols that are performed. And at the fourth, then there is a network layer with a group of functionality, and our discussion topics is related to this network layer. And the fourth layer is the transport layer, where there's a TCP, transfer control protocol, and the user data protocol that performs operations. However, we are discussing just the network layer. Now, in the network layer, different IP protocols are used. We already talked about that in our previous sessions. And for that, there's an addressing conventions. We discussed that thing. And then there's a format for the datagram that has to be packed and handed over to the either to the upper layer or to the lower layer. And then there's some this protocol defines some packet handling conventions. We already discussed these conventions in the previous session. Then there is an error reporting mechanism. We call it ICMP protocol, and it's used for signaling purposes as well. So it's also the responsibility of this network layer that apart from that IP protocol and ICM protocol, it also has another functionality of executing or operationalizing the routing protocols, and that's used for path selection and then forwarding that data or that frame to that particularly path. And the different protocols, RIP, OSPF, and BGP, they are the inter and intra autonomous system protocol that are part of this particular network layer, and the routing table updation is performed at this network layer. Now, internet as a hierarchy. Now we already know this, that from the previous diagram as well, that this whole network in the diagram has been divided into three regions. We call it region A, region B, and region C. And then there is different gateway routers in the B. This is the gateway router, and similarly every region has one or more than one gateway routers. Now, this autonomous system communication or routing is known as the exterior gateway, and we call as inter-autonomous system borders. And within this autonomous system, the routers we call as inter-autonomous system interior gateways. Now, the intra-autonomous system uh, routing is also known as IGP, or we can call it as interior gateway protocols. And the most common interior gateway protocols is the RIP, which is the routing information protocol, and the OSPF, open shortest path first, and the IGRP, which is the interior gateway routing protocol. Now, RIP works on the it works as a distance vector algorithm, and we talked about this distance vector algorithm in our previous session, and that's included in the BSD Unix distribution in 1982. So it's a general basic information about this RIP. So we just want to review. We already talked about that when we have discussed in our previous topic about the distance vector algorithm operations. And the distance matrix for this RIP is the 15 hop counts. So it works up to the 15 hop counts. And similarly, for as far as the response or the exchange time for this RIP is considered, that exchange happens after every 30 seconds, and that's through a response message, and this response message is called the advertisement packet. And so this advertisement packet is exchanged after every 30 seconds. It's at 30 seconds between the routers. And similarly, for this advertisement, the advertisement is floated up to the 25 destination networks that are in the surrounding. So this is some basic information. I just want to review it from our previous discussion because this topic is related to the intra autonomous system routing. So you just want to review this thing. Now, again, diagrammatically, we want to execute this RIP, which is the Routing Information Protocol, and how this algorithm is performed, how the information is stored in the routing table. So let's consider that different networks, and we call it that X, W, X, Y, and Z, and then they are connected through different routers. So it's just a scenario in which different routers are connected to other routers that are part of different networks. So here, if we just summarize this diagram, that this router A is connected to the network W, and through network X, and to the network which is unknown. So this router has 3 interfaces, and this router has 4 interfaces. So 3 interface connection has been shown. Similarly, the other routers, they are connected to different networks, and the interfaces have been shown. Now let's consider how this routing table is updated. Here we are considering specifically this router D. We want to update that table, or we want to see how this data is updated in the routing table using just considering this router D. So the destination network for this routing table D is, if it is W, if it wants to reach W, so the next hop count is A. You can just look into it, that, and the number of hop count for that is 2. Similarly, from this D, if the destination network is Y, so the next router to be followed is B, and the number of hop count is 2. So similarly, the other information is updated in the routing table accordingly. So this is how that distance vector algorithm executes and store the information in that routing table. Now there is some issues related to link failure and recovery in case of routing information protocol, that if the advertisement packet is not heard after 180 seconds for any interface by the neighbor router or the neighbor network, so that link is declared as a dead link. So it's basically a fault, a link failure and recovery mechanism, that if advertisement packet is not received by any router about the neighbor, that link is considered as a dead link. Now routes, so no information is routed via that neighbor invalidated link, and new advertisement is sent to the neighbor accordingly about that link that is dead, and the neighbors in turn send out new advertisement if the table is changed. So the link failure information is quickly propagated to the entire network. So if one node has just declared that link as dead, so this information is shared shortly with other neighbor networks. So the failure link information is shared in a very short span of time to the entire autonomous system or between the autonomous systems. So the poison reverse mechanism we already discussed in our previous session when we were discussing about the routing protocols, is again used to prevent the ping pong loops, and the 16 hope count is used for that purpose, that if the packet cannot reach to the destination up to, and it covers and it is forwarded to different network and the number of hope count is 16, so it is killed. So that will help to avoid the congestion of irrelevant packets that is flooding, that is moving around in the network. Now the RIP table processing, that RIP routing tables is managed by the application level process, and we called it a router daemon. We called it as route D, and D stands for daemon. So the advertisement packet is sent in UDP packets because it's a fast way of communication, and TCP is a bit time consuming, and this UDP packet for advertisement is repeated. So this is just again the view of that OSI layer 4 models out of that 7 models, in which we just look into it, that the network layer is performing the routing table information or updating of the routing information. So whether it is moving from the source to the destination, or working as an intermediate node. So this network layer is basically performing its operation for routing purposes. So let's discuss about the OSPF, which is the open shortest path first. It's again another algorithm, and that's publicly available. It's open, and it uses another type of algorithm. We already discussed about link state algorithm in our previous sessions. It's basically the LS packet dissemination. So we will be talking about this OSPF, open shortest path first algorithm, in the next session of our presentation, and this is the reference from which the content has been taken, and you can just consult it for details. You can just ask you any queries on the email that has been shown on the slide, or on my WhatsApp number, which has already been shared. So thank you very much for patiently listening this lecture. Take care. Allah Hafiz.